Hello, I'm Eric Snodgrass, and thank you for watching this Thursday night in-depth ag forecast brought to you by Nutrien Ag Solutions. I've just been thinking a lot over the last several days about the origins of the pattern we've seen in this early winter. And I think it's informing me a bit on where I think it's all going to go. And I want to share that with you tonight, kind of let you know what I think is happening and some troubles I'm having with some of the longer range models, but some of the fundamentals that I think will be affecting the weather. So let's dig into it. You've been watching an animation that was actually made back on December the 6th. And the massive winter storm that entered Saturday into the West Coast, that's the one that dumped 4 feet of snow in the Sierra Nevada mountains, has then taken a long time to get where it is today, which is over the Great Lakes, and then tomorrow and Saturday over the Northeast. It was this. You know, oftentimes when we're teaching new students about atmospheric sciences, we explain to them that the atmosphere is a nonlinear system that has chaotic behavior. And one of the things we often tell them is that sometimes very small features, like the flow that's coming right around this trough right in through here, being picked up by stronger winds coming off of China going across Japan. Sometimes these smaller features can grow. They can grow downwind in this case and upscale in terms of their size. And so that right there was the beginnings about 9 days ago of the winter storm we've got right now. But it's actually more fundamental to what's going on in the atmosphere as to why systems keep originating from here and making their way through the flow. And I want to talk to you about that because I think it's going to influence what we see for the rest of this month and into January. So I want to take you to the snow extent map that we've currently got. And it's just to make a point here that right now across the northern hemisphere, snow extent is very large. Now, parts of the Arctic have yet to fill in with ice. So there are a few places like in the Chukchi Sea that have been quite warm. And we've seen the atmosphere's ability to send ridges of high pressure both here and here, one over Greenland and one over Alaska. And that's perturbed a lot the pressure patterns that are over the Arctic. And when you combine that with the fact that we've had so much cold air throughout much of Russia, as an example, toward Mongolia, Kazakhstan, and then here into Canada and even into the Western United States, we actually set up for the jet stream to be able to strengthen in its speed due to a stronger temperature contrast. Now, let me explain to you what I'm talking about here. This is what the last 30 days looks like in terms of temperature anomalies. Now you see a couple of those areas I talked about. We've seen the ridges combining with the open ocean here in the Arctic, and then the ridge coming up over Greenland. That's kept pushing warm air, changing the pressure patterns over the Arctic. But where we've had this colder air at times has been into this corridor, hitting much of Russia. Even though you see warmer than normal conditions here, there's still snowpack, and it's still quite cold in this part of Siberia. But what this has done is this has pushed the jet stream to come out and around like this. And it's had a difficult time getting over the very warm water and subsequently warmer conditions in this area, which means it's been broken up south of the Aleutian Islands, which means the jet stream has then entered the northwest, out of the northwest, and systems have been resulting off of that pattern. They've come out here. We've even had at times southeastern ridging in this particular area. So I want to just show you where we've been because I have a feeling that the pattern is not necessarily going to resist going back here after we see this next couple of systems go through. So this is going to inform my long-range forecast at the end of this. Now, to really show you what the jet stream's been doing, this is just the average flow at the jet stream level wind. That's about 250 millibars from mid-November to now. And you can see the effect of where the jet stream has been, where it has fallen apart here in the Gulf of Alaska, but as it's come over and dove down like this, and then been picked up with stronger winds that have led off in this direction. There's been ridging in Greenland, there's been ridging in Alaska. It's disrupted our pressure patterns over the over the Arctic. So can you just stitch that away in the back of your mind? Because I want to come back to how this keeps leading to systems being born here, ended up, later, 10, 12 days later, producing disruptive systems in the midsection of the United States, like the one we've got now. So as the sun was setting here, and this is good, see the angle at which the sun set line is across the country? It's about to reach its maximum extent 6 days from now on the solstice, and then it's going to start to flatten back out the other direction as we finally start gaining daylight hours again. But this is our rather large winter storm. So from sun up today to sundown, here it is. And of course, it is cleared through the south. The storms were left over down here in Florida, where we did have a tornado watch. But from Texas to parts of Alabama and Georgia, clear skies. We're going to watch this system slowly meander over parts of the Great Lakes, and we're going to see what this is going to do to snow in New England. But this is a big system. There's still blizzard warnings on the back side. Something neat to kind of look at here is as I move it, you can now separate the clouds from the snow. There was quite a bit of snow that was put down by this particular system. All right, I showed this in my morning report, but I think it's valid to look at it again very quickly here. This system, remember, last Saturday came into the west, put up to 6 inches of liquid equivalent in the Sierra Nevada mountains, and then this is what it's done so far. The rain shadow effect, which we spent a lot of time talking about over the last couple of weeks, is evident, but to the north, there's up to 2 inches of liquid in this, in the snow. It will melt at some point. Some of it will blow away, and some of it will sublimate, but this is good just to see this moisture in place. But throughout the Corn Belt, good moisture return on unfrozen soil, so this is getting soaked in. And then all of this rain down here, yes, it was some severe weather coming out of Texas into the lower Mississippi River Valley, and we'll look at that again. But this has gone a long way to really kind of correct the drought problems that are here. Now, the new drought monitor, which was released this morning, is shown here. We still have about 75% of the land area of the lower 48 in some form of drought, with the greatest drought anchored in the plains and in the west. But remember, this map was made on Tuesday before a lot of this rain came out. So we're going to see next week's map really showing a lot of change in this area. And what's been most important about that, at least in terms of agriculture, is what it's done to the Mississippi water levels. We're now at 7.19 feet. And so that is above low stage. It's expected, with even just the recent precipitation, to get up there to about 10 feet. And if it wants to return to where it was this summer, we've still got, in some cases, another 15 to 20 feet to go. But this is enough water in the river now to allow for movement of barges and things like that. So that's just kind of one of the consequences of what this current system did and the two systems before it. Because remember, before that, we had a big subtropical ridge feeding in moisture into this area. Okay, from here, I do want to just mention quickly what happened with the severe weather. So I'm going to take you back to the 13th. Remember, we saw the storms that went through in north of Dallas, and then multiple reports of tornadoes that went through parts of Louisiana into Mississippi. Right now, the Storm Prediction Center has collected 32 reports of tornadoes. And then we see the reports from last night. Another 35 have been added for tornadoes. And at one point, as we were watching from Louisiana to Mississippi, I was just, to be honest, I was amazed at what I saw in the radar data. I'd like to show it to you very quickly here. So this is just a view, a snapshot of what was going on at that time. This was around noon yesterday, and what you see here is there was the main frontal squall line that was back here, but each of these discrete storms out ahead of it were actually supercellular, which means they were spinning. We can see that if I flip this over to velocity, you'll start to see the couplets in this. So if I kind of zoom in, this is where we have the rotation being detected by the radar, and that was where we were seeing so many of these storms just spinning away. Now, it's kind of interesting. As I went back to this, I remembered something I was thinking about yesterday. Oops, let's go back and see that again. You'll notice that coming out of Jackson, where the radar is, there is something going on right here. See this interesting beam? In fact, if we play this, if I can get this to load quickly enough, you'll notice that that's kind of a permanent feature right into there. So I want to talk about what's actually causing this right here, this interesting feature we see in the radar. So I'm going to go back to our web browser, and I just did a Google search for Jackson, Mississippi. Now the radar is located over here in a town called Brandon. And as I zoom in a little closer, I'll tell you right where the radar is located. It's here. In fact, it's amazing what you can do with Google, but that is the radome right there. So the radar is sitting inside of that, and if you zoom back out a little bit and come across the street in this direction, let me zoom out a little bit more, what you'll end up seeing is right over here, there's another very tall object. That is not a radar, and as you can see, it is the Brandon Water Tower. That water tower is what's blocking the beam right here. And we lose all of that radar data in that area because the water tower is too close to the actual location of the radar. Now, just, of course, that's secondary to all of the supercells that were erupting out ahead of this. And we're just now seeing today the full extent of the damage from this event. And it's truly horrific how nasty these storms have been. And they're going to be cleaning up for a very long time from this. But I just wanted to explain some of the neat stuff that you do see on radar here. Okay, let's go back and come back to where we need to pick up with this forecast. How about right here? This is where we currently have our all hazards weather map this afternoon. In fact, let's get an update on this. There we go, about 4:20 this afternoon. This is all ground blizzard. There's still some snow flying in the sky, but the strong winds in the back of this are still producing blizzard warnings throughout parts of Nebraska, North and South Dakota, and even eastern Montana. Winter storm warnings to the east, including over into parts of Minnesota. And then we have winter weather advisories into Wisconsin. Now, the second set of winter storm warnings stretches in through parts of New England here, where we're going to take a look at the snowfall totals in a second. And that includes the ice storm warnings that are here. Down to the south, this is all flood warnings that are out on the major rivers that kind of eventually feed into the Mississippi River down here. We've got very cold air that's coming into California, but I'm going to talk to you in a few moments about what we expect across the west in terms of temperatures with this next setup, because it's going to be quite brutal going through. First, where is this current system going here? So let's blow this up so we can see it. And this is today's 12Z NAM. Let's just pick this up late this afternoon and watch the snow spreading through parts of New England this evening. It's going to come in a couple of rounds as the upper level low still sits over parts of the Great Lakes. So this system continues to produce the strong winds on the backside. That's the effect of the ground blizzard. And there will be convective snow bursts that surround this throughout parts of Iowa, Wisconsin, Illinois, Indiana, Ohio, even to Pennsylvania and Michigan. And they're going to put down some locally very heavy snow. And then on the back side of this, as this low finally curls its way out by Sunday, there will be some lake effect snow that comes off of this as well. Just taking a look at how much snow was expected in New England out of this, we can see that several of the models are still putting 6 to 18 inches into parts of New England here. It's mostly in the interior, but some of that's getting right over here into parts of Vermont and New Hampshire, and then into parts of Maine as well. So this is just kind of the last-ditch effort for heavy snow out of this system as it finally moves off to the east. Now, after this, I know it's amazing just to think, oh, we've got one out. What's next? We're watching right here. It may not look like much, but today, in the upper level wind flow, we're watching a feature over Alaska. And that feature will eventually get put over parts of British Columbia and team up with two other short waves, such that during the week of Christmas, it is trailed by a large Arctic outbreak and potentially set up a very active storm path through the central United States and possibly a highly disruptive storm system up the East Coast. And I'd like to talk to you about what that is. Now, first, I'm going to show it to you in terms of the height anomalies, because this will tell us why this little wave is going to become such a big feature downwind. You see, there's still a lot of high pressure in the northerly latitudes. And as I play this forward, we get a sense of some blocking in the atmosphere. Like, for example, coming around this trough, this large ridge, this gives us what we call an omega look to the flow pattern. It's not fully blocked up, but it is an omega look. Now, this ridge, which is building right in through here, has already displaced the shortwave. Now, remember, that was the feature that was over Alaska. By Saturday, it's now creeping into parts of British Columbia. And then what we see by Saturday night into Sunday, and from Sunday into Monday, is it sits right here as these two large ridges, which displaced that, move into the Arctic over the Chukchi Sea, and here between the Hudson Bay and Greenland. Now, why this is important is this is going to reinforce the behavior of the cold air that's in this trough. And this trough on Monday into Tuesday looks very unassuming, but it is actually setting up for a massive Arctic outbreak. It's hard to see because of how shallow the cold air mass is. That's why you don't see the upper level heights looking as cold and therefore as low as will be indicated by the depth of this cold air. But all of this cold air is because of the displacement by this ridge of the cold air that was over Alaska and the Arctic, and it is now living right here. Now, there's some, I don't know if I want to call this, but some gentle ridging that's happening over the west. That's going to be critical for their temperature pattern. But starting midweek next week, that trough dives into the plains. Out ahead of it, this front is going to kick off some snow and very cold air behind this. It's going to come right here over parts of kind of the the Midwest, Tennessee Valley, Ohio Valley, and that is where it's going to get deep and start to deliver some very strong curvature in the flow. That translates into the development of a low. And it is still quite possible that by the 22nd into the 23rd, this produces a highly disruptive storm system over parts of New England. Now, I want to show this to you in a couple of different ways. There is, as you see here, some very, very cold air that is coming down with this system. I'll just park this out here. Let's just start this again with maybe next Tuesday. So what we're looking at here is temperature anomalies from the European model next Tuesday, Wednesday, into Thursday. Now, do you notice how it seems to be very difficult for the air to get past the Rocky Mountains. This is a very shallow, cold, high-pressure system, and it does not have the ability to climb over the mountains to get into the west. Hence, the west has more moderate Pacific air in it. So this doesn't invade the west. If you're out in the west and you've been looking at your forecasts and they've been all over the place, it's because the models earlier in the week could not figure out if this was going to be so shallow that it couldn't make it over the mountains. The data we have now is that it is too shallow. But you notice that getting in here toward the 22nd, 23rd, and eventually toward Christmas Eve, that shallow cold air mass advances very quickly through the plains and sets up the nose of it here to develop what we call a baroclinic zone, to develop a large East Coast cyclone. Now, how cold is this going to be? Some of the air in through here will have temperatures that will be up to 40 degrees colder than the climatological average. And if I just switch my view here and go to a central United States view, you can see these are the temperature anomalies, 35 to 40 degrees colder than normal. The actual temperatures, if I just take this out here, there we go. We'll go to Friday morning on the 23rd. The actual forecast temperatures are in the minus 20 to minus 30 range in parts of the Dakotas, and the single digits to negative single digits here. And we're going to talk about teens all the way down into parts of the southeast. This has been a pretty robust signal in the model. It's showing up very, very cold. But what I think is most amazing about this is how shallow of a cold air mass it is and its inability to get over the mountains, which means the Rockies are going to serve as a guide to shovel this air in this direction rather than letting it spread. And just to show you that, I pulled up one of my favorite sites here, pivotalweather.com, where you can get forecast soundings. Now, this is in eastern Montana. And we're out there we're out there looking pretty far in the forecast a week from today. And I want to show you the surface air temperature is minus 19 degrees Fahrenheit. The temperature at, 500 millibars. This is about, roughly 5 kilometers above the surface of the Earth, or about 3.5 miles. The temperature up there is going to be much, much warmer. And it's just incredible to see that basically from the ground to this point, we're nearly isothermal with a warm-up happening at 500 millibars. So it is going to be warmer up, at the base of where some of our regional jets fly than it is going to be down at the surface because of how shallow and cold that particular air mass is down here. I'm just fascinated by this particular setup. So what do we end up getting out of this? Well, it lasts. The new GFS ensemble run keeps that really cold air locked into place here through Christmas. And the newest run even wants to leave it across parts of the east all the way out until the end of this year and the start of January. Now, this particular pattern is not linked up with any sort of a polar stratospheric polar vortex disruption. So I think it's going to be transient. I think it'll be cold for 10 to 15 days, but it's not the type of pattern that just leaves this part of the country in deep cold for a month or 2 months. We're going to moderate, but remember, we're going to moderate right about the time we start, what is normal winter. So to moderate in winter does not mean it's going to go back over warm. But you can tell how the pattern's going to be. The flow is going to come over the top and then dive down like this. Now, what's really interesting is we're going to do a multi-model analysis of this particular pattern. And for the last several days, the European model has been performing much better. Just today, the GFS made a big jump up in its performance, but it's now back up to where the European has been performing. We're going to look at both models in a second. But this is where I think this pattern is really fascinating. Now, there's a short wave right here. Okay, this is the big low that's going through now. But I need you to watch this guy, because it's going to end up teaming up with, over the next week, 2 other waves. Now, watch this with me. Remember, these short waves of vorticity just tell us where there's cyclonic spin in the atmosphere. They make lows. Okay, they make low pressure systems. So that short wave, as I play through Friday into Saturday, let's just stop it here on Saturday. It's now there. That's it. It's moved farther to the south. Now, what I want you to watch is through Sunday, it's sitting right over British Columbia. And there's a wave here, and there's actually a little wave that's following it right there. Now, going from Sunday into Monday and Tuesday, we have a wave. Well, let's stop it here Monday afternoon. We have a lead wave that's going to kick off some showers and storms early next week down in the south. We still are waiting on this wave to come through. So there's 1, 2, and here's the following wave. Now watch. The European model on Tuesday into Tuesday afternoon, there we go, has got this lead wave jumping out. It's got the southerly wave here and the wave that follows there. On Tuesday, there's going to be a reinforcing shortwave that comes in on the backside. Look at that, 1, 2, 3, 4. And what will end up happening in this pattern is that going out toward Wednesday and Thursday. Ready? Lead wave out, following wave here. First wave that was in Alaska there, the kicker is there. This is so, sorry, I always find this fascinating. And what this might do is that on Thursday, we could get the lead wave here coming out of the Gulf, making what we call a Miller Type A low pressure system. That's a big East Coast cyclone. We could then have the second wave coming through the Midwest, giving us what's called a Miller Type B system going up. And all of this is happening the day before one of the busiest travel days in U.S. Now, how do we stitch all that together? Because this is just what the jet stream is going to be doing in terms of producing vorticity. Well, first thing is this. I went and looked up. I told you I'd do this morning, but it appears, according to a Weather Underground article, that the record set for highest air pressure was in Miles City, Montana in 1983. Interestingly enough, I believe that was a La Niña winter, and it was 1064. This morning, some of the models were suggesting we could get that high pressure. I then confirmed it with some INCEP data, went to their all-time record high pressure, and it says right up here 1063 would be the record. You have to put a 10 on the front of this to see it. So that was in Montana. All right, from there, what did the models suggest? Well, this is system number 1, the one we've already seen. It's going to curl over the Great Lakes, snow in New England. Remember, that snow's still coming this weekend. And then after that, things are a bit quieter. This is that lead wave, the one I told you about that comes through Texas. It's in both models. The GFS is more aggressive on the northern side of it. Will there be snow here next Monday? I have no confidence in telling you that there will. It's out of the European now, but we'll keep an eye on that. This is midday Monday, possibly some snow into Kansas and Missouri. But you see how quickly it fades? I think the Europeans got a better handle on that wave, staying farther to the south. That's showers and thunderstorms next Sunday night through Monday, right in through this area and eventually into Tuesday morning. Now remember, that wave gets way out over the ocean as the big short wave, the one that was in Alaska, comes into Idaho and Montana. It's actually in both models. The Europeans just more aggressive with it. So that wave comes down, and as it is pushed by very cold air on the backside, we could possibly be seeing in here frontal snow. In other words, the front is just lifting the air, producing snow. There's no deep low pressure system here yet, and that's in both models. Now remember, while this is happening, there's a wave sneaking underneath this right down here, okay? At this point, this is Thursday, we have our Miller A system, which started here and is now sitting there by Thursday morning. This is the beginning of the Miller B system going through Missouri and Illinois. Could it put down some snow? Yes. I'm not prepared yet to show you a snow map for this, though. And as that system comes through, this is when the trough gains some curvature. We see a low developing somewhere between West Virginia, Kentucky, and Ohio. On the backside, very strong winds, very cold air, very high pressure. We'll take a look at that in a second. And then what you have is your Miller A is there. Your Miller B is coming in like this, and they both go racing up the East Coast. The GFS has a different scenario. The GFS lags both of those short waves and pulls them together right here. And it's trying to kick off a system that starts and then rolls up the East Coast. And I got to be honest with you, when I saw this, the first thing this reminded me of, it's a little different, but it reminded me of the storm of the century in March of 1993. Because will you just keep your eye over here on the GFS? Watch this, I'll go back. It brings all of this together over Alabama, Georgia, North and South Carolina, produces a squall line that goes through Florida, and then rolls up the East Coast, delivering just tremendous snows all the way to the coast. Now, of course, as atmospheric scientists, we look at this and it's exciting for us to look at this. If this manifests itself and happens, this is going to be a highly disruptive storm system before a very important holiday. And it's going to hit the megalopolis that is the East Coast. It's going to be delivering brutally cold air on the backside. And there's a chance that we could start to flirt with that record high pressure. I'm going to show you what I'm talking about. I'll zoom in here. In fact, let's go look at the European. Will you watch right here in Montana? As we go forward, we see that the high pressure coming in behind this, inside these contours here, will be about 1055. So that's a lot lower than what we saw today, but somewhere in the 1050 to 1055 range, which means I don't think we're going to break the all-time record in Montana. But this system going up the East Coast we got to be watching it carefully. Now, in order to gain support in this forecast, we need to look at the ensembles. So what I'm going to do next is I want to show you an interesting forecast. I've shown it to you many times in the past. It's when you put together all 51 of the European ensemble runs plus the operational one, and you look at the position of where the lows are. So there's an L over the low pressure center in every run. So this is today, right now. They all line up. They're on top of the same spot. You'll see them start to split, though, as you go forward. So see how by Saturday, 54 hours from now, the models have split where they think the low is going to be. There's one here and there's one there. Now, we're going to watch that one go out. It's gone. Here comes the high pressure on the backside. This is Monday, Tuesday, Wednesday, Thursday. So that's the brutally cold air that comes in. Now, by next Thursday night, do you see how the model is beginning to cluster several low pressure systems here? This is each one of the different 51 members of the ensemble. They're all slightly perturbed from one another to give a spread, but they all are trying to go after the same system here. So this is next Thursday getting into Friday. And what it says is there's increased confidence that there could be a large and disruptive system at this point, just 2 days before Christmas, rolling up the East Coast with, just ridiculously cold air on the backside. And to finish this whole story, before I get into the long range, this is what we see by Christmas. The jet stream, which has resisted coming off of China, extending across the Pacific, now appears to be diving into the Pacific Northwest, which means it is no longer busting up like it had been in this area, at least according to the models. It also seems that it's going to be set up where we have a little bit of a positive P&A pattern. There's a ridge there, which means troughs dive in and then eject like this, which means going forward, this pattern could continue to be very active, not only through Christmas, but possibly even a little bit beyond that. Now, let's spend some time talking about the beyond that, okay? And the first thing I want to do is just remind you that from the 23rd to the 29th, NOAA continues to show that this whole region outlined here has a high risk of seeing very, very cold conditions, especially between the 23rd and the 25th. So we need to be on the lookout for the extent and duration of that very cold air hitting at a critical time. And this is going to be very rough in the northern plains, where the low temperatures could be 20 to 30 degrees below 0 degrees Fahrenheit. And that could be, that's detrimental to cow-calf operations. Ranchers, this is something I'm quite concerned about. But then we say, well, what happens after that? So when we look out there at the new model run, the European model just again did exactly what it did on Monday. It just says, no, after this, the pattern's going to go drier here and drier in California. It's going to be wetter in the Northwest. And I just can't buy it. It does not make sense to me that this is what the pattern's going to be. And you say, well, why not, Eric? I said, because the models keep advertising an extension of this jet. And we put all this cold air in place. It's got to do something. If anything, it's going to invigorate the jet. That's why the jet stream exists. It's a feature of contrast. The jet stream only exists because there are strong contrasting temperatures. So I look at all of that and I say, I have to depart from trusting the European model. And I usually trust this, but if I have reason to not trust it, it's this. I got a little boost of confidence today, though, because NOAA released their new forecast for the month of January. And I definitely buy it because we still have a La Niña. We still have this pattern in the Pacific that is helping to create an active jet stream pattern across the United States. It's probably going to enter through the Northwest and eject through the Ohio River Valley. If there's a place that's drier, I would just anchor it into this area, western Texas into Arizona and New Mexico. I would not even extend it into the Central Plains here. But this is by far a better look at the month of January than I think we're getting from the European model right now. So I'll tip my cap to CPC on this. This makes sense to me. And to kind of build on why I think this makes sense, I want to show you a couple things. If we have a La Niña, which we do right now, in January, where is it typically wetter? Here and here. Why? Jet stream likes to come in and eject. We tend to be drier in this area and a little bit drier in the southeast. But if you have an active storm quartering through here, you're going to be bringing fronts through the southeast, which will help with the precipitation there. But that's why I really like this forecast from the CPC. So what's going on right now? Well, we have had for a while a lot of high latitude blocking, like this ridge here and the big one there. Will we see more of that? Will this continue to give us flow that comes over the top and then dives, possibly getting a little bit of southeast ridge? Sure. The patterns favored that up to this point. We might continue to see something like that going forward. So if I just think about that, I want to let you know something again. The teleconnections, the long-range teleconnections, are still not advertising strong signals one way or the other. They are saying there might be a slight positive bias to the P&A. That's weak ridging over the west. They are saying that the Arctic Oscillation may be more negative throughout much of January. That's the high latitude blocking helping to keep things cold. Same thing with the North Atlantic Oscillation. But I want you to know the spread in the European model is high, which is why I look at this forecast and I say I get why it's just going with persistence from the very near-term forecast. And I think that's what's going to be the problem with it. I still think that even though this La Niña is likely at its peak right now, its influence will last at least through the beginning of January, maybe a little bit longer than that. Why do I think it's at peak? Because these trade winds right now, from now through Christmas, are some of the strongest I've seen. And they're going to push right in through there. The westerly wind bursts are here, and this is what we talked about in the video on Monday, so I know you know what to expect. So this particular setup, will we continue to see these past the middle part of January? There will be weaker trade wind patterns, but it's going to start to let go. And I just want to provide another piece of supporting evidence for why I think that's the case. You see, when you look historically, I went back to 1990 here. Every time we've had a La Niña episode, which are the spikes down, they typically reach a peak right on the grid lines. And what do the grid lines mean? The beginning of a new year. So January 96, fade. Here you go, 98 or 99, fade. 2000, fade. 07, 08, you can see all of them start right after Christmas, their fade. And of course, I don't know if you all know this, but that's what El Niño is named after anyway. El Niño is Spanish for the little boy, and the little boy that we're talking about is Jesus Christ, the Messiah of the Christian faith. And now that talks about the spikes up, but the spikes down, La Niña, are the opposite of that. So the reason why it got its name is because of the arrival of the warmest water happens around Christmas. The departure of the coldest water happens around Christmas. It's done that, and almost every year going back, not up to 1990, but even farther, except for last year. Last year was the only year that I've seen where instead of moderating after the beginning of January 2022, it just stayed around. Stayed around all the way through till now. But could it do that return? And then the big question is, after this point, does it just return back to neutral or does it overshoot? I think there's reason to start to think we could start to get an overshooting of this. So my point right now is that La Niña is probably at its peak. And yeah, it's influencing the pattern as we go forward. But I think it's going to start to back off. New data for the long range even reflects that. This just came out. This is the IRI multi-model probability forecast from Columbia University. They do a statistical analysis of the long range models. And this is their new forecast for us here in North America for January, February, March. And I've bought into this hook, line, and sinker. So what does it mean? Still get a pattern that likes to come in like this. More moderated, though, and eject through the Ohio River Valley. But they have now shrunk the area that's going to be drier here, and they're suggesting some southeastern ridging, which is why Florida is showing up on the drier side of things. That's an active look. And what's important about that is, if this verifies, if we see this actually as the pattern, and by the way, this is a pattern that sets up repeated shots at colder air. Okay, but if this verifies, I think we're actually going to see this map verify too. I was just on a call this afternoon with some folks, and I said, I think drought is going to be reduced by more than 20 to 25% by the time we get into spring. They said, where? I said, in the Midwest, in the North, and in the Northwest. And it's just great to see that NOAA must be on the same wavelength as I am, because they released this right after I mentioned that. They've got drought improvement here and here. Now, we could all be wrong, of course, but the evidence is pointing toward that being the case. What about the Central Plains? They may have to wait until April before this pattern opens up into a possible El Niño situation to deliver better flow into this area, and that is very possible. If you just think about why that might be the case, you've got over South America, across the Pacific Ocean toward Australia, the trade winds still driving the colder water upwelling. The moment those trade winds let go, see all this warm water here, which is down about 100, 150 meters? it sloshes back. And that slosh back only happens if you get rid of the strong trade winds which are going this way and let the strong westerly wind bursts move. And I just think there's evidence for that to occur. So what does that mean? March to June, everywhere that you see warmer colors, we tend to see wetter conditions for spring. That's tighter planting windows, I get it. But boy, if that happened and we could help eliminate the drought here as well, this is all a very positive signal going forward. Now, that's the United States. Of course, we have to talk about South America. Today's 12Z European model continued very wet conditions across Brazil's northern and central growing areas, drier into parts of Paraná, down to Rio Grande do Sul. Very dry in parts of Argentina, according to the model, and into Paraguay and Uruguay. Now, there's a lot of question about where this might end up as we go past the start of the new year, because this is certainly going to be the case going forward. This will help support a large crop north, but it's going to continue to cause problems in Argentina. Just thinking about that, I got asked today, well, what does it mean if we end up getting rid of La Niña and there's an El Nino? There is some, and this is speculative, some risk from March to June that if you warm up those ocean temperatures and bring in El Nino conditions, that we have drier risk on the safrinha crop. But that's about all I can state about it right now. We don't yet fully know if that's going to be the case as this goes forward. What we do know right now is that the drought we've talked about for weeks going on in Argentina continues to be pushed down the road by the current forecast. So we had a lot to cover today. I appreciate you hanging on with me with this. I enjoy this so much. I appreciate all the feedback you all give me. But this is my latest thoughts. So I'll keep processing it. Think about it next week as well. Next week will be my last forecasts for 2022. I'm going to take the time off between Christmas and New Year's to spend with family, and then we'll pick right back up in the new year. Appreciate all your attention. Thank you.